Just below the lovely scenery of Geneva, Switzerland, lies an amazing piece of engineering, the Large Hadron Collider, or LHC. This huge machine is not just an engineering wonder, it's also a gateway to the secrets of the universe. The LHC shows how we never stop trying to find out more about the world around us, how we're always curious, and how we're determined to understand the basic secrets of existence. It challenges what we thought was possible, and with it, we're getting closer to understanding the very fabric of reality. The Large Hadron Collider is the largest and most powerful particle accelerator ever built, spanning 17 miles in circumference. This huge underground ring is fitted with superconducting magnets that can accelerate protons to almost the speed of light. What we're aiming for is, the idea is to smash these protons together in high-energy collisions, recreating the conditions that existed just moments after the Big Bang. These collisions, which occur at energies that are almost beyond our comprehension, allow scientists to peer into the fundamental structure of matter, uncovering the building blocks of the universe itself. But the LHC isn't just a tool for understanding the cosmos. It's also a symbol of the need to find a balance between human curiosity and the potential dangers that come with pushing the boundaries of science. The LHC has opened the door to possibilities that were once the stuff of science fiction. As we explore the unknown, we also have to think about the risks and responsibilities that come with such powerful experiments. Physicist Brian Cox, a big name in particle physics, made a statement recently that got people talking in the scientific community. He dropped a hint about a mysterious discovery at CERN, the European Organization for Nuclear Research, where the LHC is based. While we don't have all the details yet, this discovery could have a big impact. What could CERN have discovered? Is it something that challenges our current understanding of the universe? Or does it raise more questions than answers? The LHC is more than just a machine. It represents the cutting edge of human knowledge and the unknown forces we're trying to understand. But it also makes us think about some big questions about existence. As we push the boundaries of knowledge, are we heading for a disaster of our own making? The LHC's incredible power lets us explore the depths of reality in ways that were once unimaginable. But with great power comes great responsibility. What are the potential risks? Could our experiments accidentally set off a chain reaction that gets out of control? CERN was set up in 1954 and has grown into one of the most prestigious research institutions in the world. CERN is a hub of international cooperation and scientific advancement, with 23 member states and thousands of scientists from across the globe. The LHC is the jewel in CERN's crown when it comes to research, but it's just one part of a huge network of particle accelerators. These machines are pretty complex, but they've got one simple goal: to accelerate subatomic particles to incredible speeds, creating collisions that allow scientists to explore the fundamental building blocks of matter. The LHC is housed in a massive underground ring, located 574 feet beneath the Earth's surface. This underground location protects it from cosmic radiation, which means the LHC can function with incredible precision. Inside the ring, two beams of protons are accelerated to almost the speed of light, guided by a series of superconducting magnets that have to be cooled to temperatures colder than outer space, just 1.9 degrees above absolute zero. The magnets need to be kept at a really low temperature so they can work at the level of precision needed to keep the protons on their paths as they race around the ring, an astonishing 11,245 times per second. At 4 points around the LHC, the proton beams are directed into collisions that produce temperatures millions of times hotter than the center of the sun. It's at these collision points that the real magic happens. The LHC has 4 big detectors: ATLAS, CMS, ALICE, and LHCb. Each of these detectors has a different job to do, focusing on different aspects of the collisions to gather as much data as possible. These detectors are like huge cameras, capturing what happens after the collisions in amazing detail. This lets scientists look through the debris to find new particles and phenomena. One of the most famous particles discovered at the LHC is the Higgs boson, often called the God particle. Its discovery in 2012 was a huge moment in physics, confirming a theory that had been proposed nearly 50 years earlier. The Higgs boson is a key part of the Standard Model of particle physics, which describes how the building blocks of the universe interact. It's what gives other particles mass, and its discovery was a huge step forward in our understanding of the universe. However, the LHC's mission is much more than just finding the Higgs boson. One of the most intriguing mysteries it aims to solve is the nature of dark matter. Dark matter is an invisible substance that doesn't emit, absorb, or reflect light, so it's impossible to detect with traditional methods. It's thought to make up about 27% of the universe, which is a lot more than the ordinary matter that makes up stars, planets, and everything we can see. The LHC's experiments are designed to produce dark matter particles in a laboratory setting, which could provide valuable insights into this elusive substance and potentially revolutionize our understanding of the cosmos. Another area the LHC is looking into is the possibility of extra dimensions. Some theories suggest that our universe may have more than the 4 familiar dimensions of space and time. These extra dimensions could help us understand some of the mysteries of physics, such as why gravity is weaker than other fundamental forces. If these dimensions do exist, the LHC might be able to detect them by looking at how particles behave at extremely high energies. If we can prove that there are extra dimensions, it could change how we understand reality and open up a whole new area of scientific exploration. But these groundbreaking experiments also bring with them some significant risks and ethical considerations. The LHC is a very powerful tool, and there are some risks involved in its experiments. One of the most controversial possibilities is the creation of miniature black holes. Black holes are areas of space where gravity is so strong that nothing, not even light, can escape. The idea that the LHC could produce such an entity, even on a microscopic scale, has got people both excited and concerned. The scientists at CERN have reassured the public that any black holes that might be produced would be unstable and would disappear almost immediately. They've carried out lots of safety checks to make sure their experiments won't harm our planet or the universe. Even the possibility of creating a black hole, however small, has led to debates and fears about the potential consequences of these experiments. To understand why the LHC might create a black hole, we need to look at how particle accelerators work. When protons are accelerated to near light speeds, their energy becomes so immense that it can warp the fabric of space-time itself. Think of a trampoline that's been stretched really tightly with a heavy object on it. The fabric bends under the weight, creating a depression. If the object is heavy enough, it can create a deep well that pulls in anything nearby. This is a simple example of what might happen at the LHC, where the energy of the protons could create a small black hole. The LHC's experiments have even caught the attention of some of the world's most renowned scientists, including the late Stephen Hawking. In his work, Hawking warned that the Higgs boson could become unstable at very high energy levels. This instability could lead to a catastrophic event called vacuum decay. This is a sudden and unstoppable change in the nature of the universe that could annihilate everything in existence. Another well-known scientist, Sir Martin Rees, the British cosmologist and astrophysicist, has also shared concerns about the experiments conducted at CERN. In his book about the future of humanity, Rees looked at the potential dangers of particle accelerators. He talked about the chance of a destructive experiment causing a phenomenon called vacuum instability. This could theoretically lead to a phase transition that would affect the fabric of space-time, resulting in a catastrophe of unimaginable proportions. Despite these concerns, CERN scientists have done their best to assess the risks and say that the chance of something going wrong is very small. They've taken every precaution to reduce the risk of any potential dangers, and they believe the benefits of their research outweigh the risks. The LHC has already given us some amazing insights into the nature of the universe, and it continues to push the boundaries of our understanding. As we keep on exploring the unknown, we need to be really aware of the ethical and existential questions that come up. The mysteries of the universe are not just interesting to know about, they are powerful forces that can help us understand more about how the world works. But there's also a chance they'll unleash forces we can't control. The LHC is our boldest attempt yet to answer some of the biggest questions about existence. But it also shows us the responsibilities that come with such knowledge. As we stand on the brink of new discoveries, we must ask ourselves, what price are we willing to pay for knowledge? Can we ensure that our quest for understanding does not lead us down a path of destruction? The LHC's immense power allows us to probe the depths of reality in ways that were once unimaginable. But with great power comes great responsibility. What are the risks? Could our experiments inadvertently trigger events that spiral out of control? CERN, founded in 1954, has grown into one of the most prestigious research institutions in the world, with 23 member states and thousands of scientists from across the globe. CERN is a hub of international cooperation and scientific advancement. The LHC is the crown jewel of CERN's research efforts, but it's just one part of a vast network of particle accelerators. These machines, despite their complex nature, have a simple goal: to accelerate subatomic particles to incredible speeds, creating collisions that allow scientists to explore the fundamental building blocks of matter. The LHC has already achieved incredible feats, from the groundbreaking discovery of the Higgs boson to the ongoing search for dark matter and extra dimensions. But its true legacy may not lie solely in the answers it provides, but in the profound questions it raises. The universe is vast, mysterious, and far beyond the full grasp of human understanding. The LHC serves as a window into these cosmic secrets, allowing us to glimpse the very foundations of reality. But as we look into the unknown, we also have to think about the limits of our knowledge and the risks that come with what we find out. The LHC is a great example of what can be achieved through collaboration. It represents the work of thousands of scientists, engineers, and researchers from all over the world. It's a shining example of international collaboration and scientific ambition, but the questions it's trying to answer go way beyond what's happening in the LHC's tunnels and laboratories. The Collider is delving into some of the most fundamental mysteries of the universe, questions that have puzzled humanity for centuries. One such mystery is the nature of dark energy, which is driving the accelerated expansion of the universe. Dark energy is even more of a mystery than dark matter, making up about 68% of the universe. Unlike dark matter, which has mass and interacts through gravity, dark energy seems to be a property of space itself, influencing the universe on a cosmic scale. While the LHC wasn't designed with dark energy in mind, the insights gained from particle collisions could help us understand this elusive force better. The LHC is also looking into the possibility of supersymmetry, which is a theoretical framework that suggests that every particle in the standard model has a corresponding superpartner. If supersymmetry is right, it could help us understand some of the big questions in physics, like what dark matter is and why the fundamental forces don't unify. If we find supersymmetric particles at the LHC, it'll be a huge step forward in our understanding of the universe. It'll open up lots of new avenues of research and might even help us understand how the universe was created. It's also worth noting that the LHC has implications for our understanding of cosmic rays, high-energy particles from space that constantly bombard the Earth. Cosmic rays are made up of protons, electrons, and atomic nuclei that travel through space at nearly the speed of light. We don't know exactly where they come from, although they probably originate from supernovae and black holes. By studying high-energy collisions in the LHC, scientists can simulate the conditions that produce cosmic rays, which helps them understand where they come from and what they do. This research could help us understand one of the most mysterious things in astrophysics and give us clues about the most energetic events in the universe. The LHC's experiments could also help us understand why our universe is made up mostly of matter rather than antimatter. The laws of physics say that the Big Bang should have produced an equal amount of matter and antimatter, which would have destroyed each other, leaving nothing behind. But we live in a universe that's made up mostly of matter, with hardly any antimatter to be found. The LHC's experiments, especially those done with the LHCb detector, are trying to figure out this imbalance and find answers to one of the biggest puzzles in cosmology. Looking ahead, the LHC has a lot more to offer in terms of discoveries. The team is already looking at ways to upgrade the Collider, with the High Luminosity LHC, HLLHC, set to go live in the next few years. The HLLHC will increase the number of collisions, allowing scientists to collect even more data and potentially uncover new particles and phenomena that have remained hidden until now. But the LHC is just one step in a much larger journey of scientific exploration. Beyond the LHC, there are already plans in place for even more ambitious projects, such as the proposed Future Circular Collider, FCC, which would be even larger and more powerful than the LHC. The FCC could look at energy levels that the LHC can't even begin to explore, opening up new frontiers in particle physics and deepening our understanding of the universe. These future projects also raise some ethical questions. As we explore further, we need to keep finding the right balance between seeking knowledge and making sure we look after our planet and the universe. As our experiments become more powerful and our ambitions more far-reaching, it's likely that the questions raised by the LHC about the risks and rewards of pushing the boundaries of science will become even more pressing. The LHC story is a reflection of humanity's broader quest to understand our place in the cosmos. Since the dawn of civilization, we've been looking up at the stars and wondering about the nature of the universe. The LHC is the latest chapter in this story, giving us the tools to explore the deepest questions of existence. But the LHC also shows us that the search for knowledge can have risks too. As we start to understand more about the universe, we need to think about the possible effects of what we do. The LHC is a powerful tool, and with that power comes a great deal of responsibility. The discoveries made at the LHC could change how we understand the universe, but they also make us think about the ethical issues around the role of science in society. Ultimately, the Large Hadron Collider is more than just a machine. It's a symbol of human ingenuity, curiosity, and ambition. It shows our desire to explore the unknown, to push the boundaries of what is possible, and to seek answers to the most profound questions of existence. But it also shows us that the pursuit of knowledge is a tricky balance. You need both courage and caution. As we continue to explore the mysteries of the universe, let's do so with a sense of wonder and humility. The Large Hadron Collider shows what we can achieve when we work together to gain knowledge, but it also shows that some mysteries are best left untouched. As we try to grasp the mysteries of the universe, we must remember that with great power comes great responsibility. The universe is a huge and amazing place, and the Large Hadron Collider gives us a peek into its most important secrets. As we keep pushing the boundaries of physics, it's important to do so with caution and to consider the potential consequences of our actions. The story of the LHC is not just about science. It's also about the human spirit, our insatiable curiosity, and our willingness to push the boundaries of what is possible. It's a story of discovery and risk, of knowledge and power, and of the careful balance we need to maintain as we explore the unknown. As the Large Hadron Collider keeps running, its legacy will be shaped not just by the discoveries it makes possible, but also by the questions it raises. The LHC is the latest and greatest thing in human knowledge. It lets us look into the deepest mysteries of the universe, but it also shows us the ethical and existential challenges that come with pushing the boundaries of science. In the years to come, the LHC will probably keep on revealing new insights into the nature of reality, challenging our understanding of the universe and our place within it. As we celebrate these achievements, we must also be careful not to let our pursuit of knowledge lead us down a path with unintended consequences. The Large Hadron Collider is a symbol of human curiosity and innovation. It shows what we can do when we explore the unknown and try to unlock the secrets of the universe. But it also shows us that the search for knowledge can have some pretty risky moments. As we keep pushing the limits of science, we need to be careful and remember the responsibilities that come with such power. Ultimately, the real legacy of the LHC might not be in the discoveries it makes, but in the way it makes us think more deeply about the nature of existence and the ethical implications of our actions. The universe is huge and still largely a mystery to us. Our understanding of it is still in its infancy. The Large Hadron Collider gives us a peek into the cosmic unknown, but it also makes us face the limits of our knowledge and the potential consequences of our discoveries. As we approach new frontiers in physics, we must do so with a sense of wonder, humility, and responsibility. The Large Hadron Collider is a tool that lets us explore the mysteries of the universe, but it's up to us to make sure that our quest for knowledge doesn't come at too great a cost.